usefulness means this guy requires a state variable to have, this guy will give a state variable a certain value, this guy happens to require exactly that value for that state variable. Now obviously soundness would be lost if you allow actions to be inconsistent. Okay, and nothing will be lost if you allow actions to be useless. Right? Because if you allow actions to be useless, then essentially it will take everything, put it here, plus its own preconditions. So this means this is a final useless action. But it doesn't do anything harmful. That's still a plan. And if you are searching with an admissible heuristic, you will make sure that such a plan, if in fact you are looking for a short plan, you will make sure that that plan won't be returned. Okay, so as funny as it might sound, actually usefulness is secondary. You don't really care if it's useful or not. It's like the medicine, first do no harm. Okay, the action should not do any harm to the state over which it's being regressed over. Okay, this is exactly what is said here. Okay, and I wrote those sentences completely without thinking about true and false, only thinking in terms of assignments of state variables. Consistency means you don't require a variable to have a value that's different from what is required in the goal. That's all. It doesn't have to be, if it's Boolean, then it will be both true or both false. If it is multi-valued, then they both have to be essentially the same value. That's all. Okay, it's fine. So that's regression. So you do this, and then when you have a new partial assignment, and if this partial assignment is holding in the initial state, then you are done. Basically, you sort of grounded it into the initial state, and you read the sequence of actions backwards, and that will be your plan. Okay, so the question, of course, is what's the advantage between regression versus progression? Relative advantages between regression and progression. And the interesting point, of course, is that in the case of progression, you do actions. I mean, again, we are doing this without thinking of heuristics first. Okay, just if you don't have any heuristics, you're doing blind search, which would be a more reasonable thing to do. Unfortunately, I can argue either way. Okay, the most obvious argument you would probably try to do, is regression has a much lower branching factor, because most regressions you would not even consider an action unless it has some useful effect. Okay, and it has no inconsistent effect. Okay, so your goal state normally probably is going to care about just a few of the many state variables that make up this world, and you are only going to consider regressing over those actions which have some useful thing to say about those particular values. So the number of the branching factor is much lower this way, whereas in the opposite direction, in the progression direction, you do an action because it's doable. The many actions can be doable in any realistic world, and much fewer of them are relevant to what you're trying to do. Okay, so it's actually very easy to be, impressed with regression, because we all believe that we never wake up in the morning and say, what should I do? Well, I'll hit myself because I can do that. Okay, that's one of the things I can do, but there's like a billion other things I can do. And what I should be doing is, I should think in the, backward way, because after all your goals are to be here at, what, 12:40. Okay, so you reason backwards and see what would help you get there. Okay, and if hitting yourself on the head helps you, for example, to remind you that you forgot to do something that's important for the class, by all means do it. Otherwise, don't do it. Okay, so it's easy to be impressed with regression. Okay, but then the point is the following. But then let's look at some combinatorics. If there are n state variables, how many states are there? Assume Boolean. If you have n Boolean state variables, how many states are there? 2 power n. Okay. Now, initial state has to be complete. What makes initial state complete for us? What restriction makes initial state? Why do we care that initial state must be complete? Complete means every state variable's value must be known. Right? Why is that? I'm just asking. You should know this. Why do we care about that? Because otherwise we are assuming the environment is completely known. Okay, so that means the initial state is completely known. There is no uncertainty in the initial state. Okay, which basically means there are only 2 power n complete states in the world. Now, goal state on the other hand is partially specified. And I mentioned this last class that the fact that goal state is partially specified is supposed to be a feature, not a bug. Right? Although oftentimes actually it can start looking like a bug. Exactly in this problem, because nobody ever says make sure B is not clear and hand is empty in this problem. I said that and it's a problem, but you humored me because you thought I'm a weird guy. People would normally say achieve A to be on top of B. Instead I said make sure that B is not clear, and it turns out B not clear is only possible when A is on top of B in this problem. There is no other way of getting not clear B. So in fact, by asking less, I made your life harder. Your boss can do this, right? I mean, your boss can essentially say, no, I'm not a micromanaging kind of a boss. I'm just asking you this. And then you take 3 days to figure out that pretty much the only way to do that is to spend all 24 waking hours in the office. There is no other way of getting it done. Okay, so he may as well have said, I asked you not to have a life, not to have a kid, not to have a wife, not to have a house, just hang around in front of me, keep doing this stuff. And then you would have said, you are a micromanaging freak. Okay, but he made you feel as if he's not a micromanaging freak because he made it, he gave you just one goal which deductively, essentially, has a single complete state. Only one state is consistent with this goal. That's micromanagement. Yes, sir.
It seems like with regression you have one of two possibilities. One is to regress to find a plan that's possible that will lead you back to the initial state from any possible completion of the goal specification. Or you could just say pick one of the possible completions.
So actually it's a good point. So what you're saying is rather than go with this, I would first figure out all the complete goal states and work on each of them. Okay. Interestingly, if I were to ask you, what does progression mean in the atomic model, and what does regression mean in the atomic model? You remember that progression and basically planning in atomic models was just pathfinding in a graph. Okay. Progression is in fact pathfinding in a graph. Regression, on the other hand, is weird because in the case of regression, you don't give a single state. You give just a couple of variables which must have certain values. So then the only way you can do search is as what you said, which is first go into the explicit graph, mark off all the states which have those properties. There will be 18 such goal states. There may be 0 such goal states. Okay? And then once you have those goal states, then you try to sort of parallelly go on them to see whether you get any of them to the initial state. When regression works, in essence, it's doing these parallel searches in one thread. But you could have bad cases where in the initial phase, you would have figured out that there is no such state which has the following properties, or that there is only one state which has that following property. Okay, and if that is the case, then the lifted search actually kills you, because basically what happens is you might wind up having partial labels that correspond to very few real states in the world. And in fact, the very few can be really, really few, like 0. Okay, in that picture there, is there a partial assignment that is true for only 0 states? Right? I mean, those of you who are looking at it intently realize which one won't work. This one, holding A, clear B, would that work? If A is being held, B can still be clear, that will work. How about this? B is not clear, A is being held. Is that what possible in this world? No. Could you have figured this out by just saying, oh, this is A, this is not A, so obviously negative, obviously there's a failure? No. In fact, the only way you can figure that there is no state of the world that is reachable from the initial state that will have this property is to solve the planning problem of reaching this state and fail. So you could try simple pruning techniques, but many of the simple pruning techniques might leave these kinds of states hanging around. And if you don't do any pruning at all, this partial assignment will be hanging around. And from a search point of view, the worst thing that can happen is a state like this will be expanded because you couldn't be bothered to realize that it's dead. And it expands and gives 18 partial assignments which are all equally dead, because dead men don't get people, dead men don't get kids, at least in search. Okay? So they're all equally dead. So instead of showing this one is dead, now you have simplified your problem into showing 18 people are dead, 18 states are dead. Which if you continue, you can make it into gazillion billion states are dead. Now one might ask, are there really that many partial assignments? There are 2 power n complete assignments. How many partial assignments are there? 3 power n. Okay. So it actually works out from the combinatorics point of view. By saying partial assignment, I'm saying I care about this, it's true or false. I mean, this must be false. I care about this must be true. Everything else I don't care. So for every variable, I have 3 possibilities. Don't care, care and positive, care and negative. So there are 3 power n. That is if I assume partial assignment is a conjunction. If I say partial assignment is any propositional formula, then how many are there?
2 power 2 power n.
It's 2 power 2 power n. Okay? So essentially you can start doing all, and then of course you can have multiple, so basically there are many more sets. I mean there are 2 power n sets for n entities. And furthermore, one dead set can be represented in many more ways actually. It's actually worse than 2 power 2 power n, because one single dead set can be represented in 18 different ways. It's like, they say one God, many names, one dead set and many names. And all of them actually lead to entailment of false. Okay, and that will kill you essentially. Okay, so in atomic case, in some sense, it's only 3 power n. But when you're thinking in terms of propositional formulas, they come in different, guises. This is dead for a different reason than this is dead. Okay, so that's the reason that explains that regression actually might be worse than progression. Okay, what's interesting, of course, is then what happens if you start doing heuristics on top of these. We'll talk about that when we get to heuristics. When we come back next class, I want to talk about partial data planning, and then I'll start talking about heuristics. Okay.